Alright, getting ready for our test. Ready? First question says to describe transformations. Okay, so I'm looking for words. How can we change the look of a parabola? So this question, you should have 4 things to write down. You should write me something because there's a negative multiplier. So this thing will flip. You should write me something for the number that's the multiplier, the number value. So would that narrow or widen? I'm trying to be tricky. It will narrow. Why does it narrow? It's bigger than 1. Yes, it's a fraction, but that fraction is bigger than 1. So that's why I was trying to be tricky. 6 to the, which direction? Right. And 1 in the which direction? Down. Okay, finding the vertex. Okay, so this one will be your HK stuff. You just have to know if it is opposite or the same. So you will get these formulas, but you will not get, like, I'm not going to tell you that info. Like, you'll just get that formula. So on your formula sheet, you should understand in a formula if it says minus, in the formula if it says plus, minus means opposite and plus means same. So you will get these formulas without obviously me telling you what to do. Okay, so I'm not going to have that on there. Okay, so should I do a 3 or a negative 3? Negative 3, and then are we doing a negative 10 or positive 10? So this one was that they were both opposite numbers, right? The slope is the multiplier, negative 4. So that means it's going to go downward. It's going to be flipped. Axis of symmetry, so that's like that, cutting through the middle of it. How do you make straight up and down lines? You need an equation that always starts with x equals, and which x value are you going to go through the vertex? Domain, left to right. So that one's continuous. Range, so the low, so in this direction the low is negative infinity to the top height of, and I find that the height of the vertex is 10. Do you notice that I have square brackets on that one, but not the other ones? Because it's an exact, it hits. Y-intercept. So the y-intercept means make x 0. Make x 0 and see what happens. So you got to do your math. Make sure you follow BEDMAS. Do the bracket, then exponent it, then times it, then move the number, add, subtract. Okay, so we have 3 brackets squared. Now we're at 9. 9 times negative 4. And then I still have to do what yet? I'd have to move the 10. Okay, and then a little quick graph here for this one. Don't worry on your test. I'm going to give you a grid. Okay, to graph, I'm going to have my little chart here, 1, 1, 2, 4, 3, 9. That's a parabola pattern. Okay, we have a slope of -4. So that's going to become -4. That's going to become -16. -36. So this thing is going to be pretty narrow, right? Because 4 is larger than 1, and obviously the larger you go, the narrower you get. So 4 down, 16 down. So on a test, I will say I expect 5 coordinates on a parabola. So these are my 5 coordinates. Okay, do you see that? Does your y-intercept make sense? You always say that on the graph. Would this cross down here at -26? Yep, because if I'm going to go 36 down, that's where it's going to hit. Okay, that's good. So now, moving on to this one. Vertex. Vertex is different when it looks like this. What do you do to get the vertex? There's not just clear numbers on this one. And we got to start our -b/2a. So I have a 2 divided by 2 times 1. So that would make 1. One comma something. What do you do to get that? What do you do to get the y value? Plug x in. So 1 squared minus 2 times 1 minus 3. Okay, slope, so what's the multiplier in front of x squared? 1. 1x squared, 1. So then it would open just up. Positive 1. Axis of symmetry, if we could cut it, x equals, and you got to find that with the x value, 1. Domain left to right. range is going to be different because this time we have a minimum. The last time we had a maximum, so that's on the test as well. How do I know if it's a minimum or a maximum? All about the slope, because the slope tells me the up or down. Okay, so now the bottom height, -4, then up. The y-intercept, so plugging in 0 for the x, that's what a y-intercept is. This one's a little bit easier, because if I'm doing that, everything disappears except for the constant term. Okay, now I've asked you the x-intercept, so I didn't ask you to do that on the last one, because on the last one it would have been a very harder one with decimal numbers. You are going to learn that next unit, but not right now. Okay, so x-intercepts make y 0. Make y 0. Okay, what is your tool for x-intercepts? Factor. Okay, that's the only thing you have right now. You're going to learn more tools, but right now, that's all you have. Simple trinomial xx. What multiplies to 3 and adds to -2? Multiplies to 3 and adds to -2. What value actually makes it 0? +3 minus 3, yep, and -1 plus 1. Make the 0. So I have put on there the 4 points that I found. So we figured out the vertex, we did a y-intercept, and we did x-intercepts. Okay, I'm also going to give this y-intercept a symmetric partner. Where would its symmetric partner be? Okay, and look at that. They connect to be a parabola. They also connect to make a 1, 1, 2, 4 pattern. Do you see all those connections? Okay, for some reason I always get students that mix up vertex and x-intercepts. Do you see visually? Those are different things, different processes. Okay, also, what can you tell me about the axis of symmetry compared to the x-intercepts? What do we always say? They're always halfway. The axis is always smack dab in the middle of them, right? Okay, create an equation of a quadratic with x-intercepts of this. So if they have x-intercepts, would we agree that they must have done some factoring? They must have done some factoring to get the x-intercepts. So how can I work backwards to get an equation? So they did something and they got this. So what would they have had in their factor line? X subtract 5 and x plus 7. Those are the factors that would have produced those x-intercepts. So these are opposite, factoring and FOIL. They're completely opposite. So we did factor, so now to get back, we're going to have to FOIL. So FOILing, x squared. So remember, the middle will add and the end would multiply. So plus 2x is what those add to. 7x minus 5x. And what do they multiply to? And a very common mistake, what's this person forgetting in their answer? Y equals. Okay, at this point I don't want 0 equals because I want to put in other things yet. So at the very end you need a y and an x variable. Okay, so we have a parabola on this one that goes from the vertex 1, negative 6. And then there's a point at 3, 6. So therefore, I must be doing like that, opening upward. Okay, so I need you to figure out your movement. How much have you moved over and how much have you moved up? So if I'm looking at my numbers, I went from an x of 1 to an x of 3. So I have moved over 2. Then on the heights, I was at a negative 6 and now I'm at a 6. So that has made me move up 12. Is that good? We figured that out? From negative 6 to positive 6, that's 12 jumps. Okay, this is the normal pattern, but I didn't follow that rule. So here's what I did. I'm looking at this line. I went over 2. I should have gone up 4, but I went up 12. So therefore, I would have had to multiply by 3. Okay, so now vertex multiplier. Figure out your equation. Vertex and a multiplier. Bless you. Okay, I'm not expecting you to write both, but here are your two options depending on which one you picked. So some of you could have done that style, or some of you might have done that style. Okay, and like I said, you'll have this so you can follow on how to plug them in. Okay, so given a chart, you have to identify partners. So that would be a symmetric partner. If I kept going on my chart, there would be another symmetric partner to the next one. Therefore, that's my vertex. Okay, let's check out what we did. So I'm going to go to the one below it. So from 0 to 1, that's over 1. You've moved over 1. And then if you were at a 5 and now you're at a 4, that has made me move down 1. So what is your slope if you're going to move over 1 but then down 1? Did you pick -1 to multiply by? If you want to check out the next pattern, it jumps 2 over and 4 down. Yeah, that's just negating my numbers. Okay, so there you go. There's your vertex, there's your slope. Write me an equation. So you have some options on how you want to write that for me. But there's just no number in the bracket. Okay, I'm not going to write this. I don't know. Is that wrong? It's not wrong, but is it weird? Yeah. It's just it's not math to write +0 on something. Okay, so there's no value in the bracket with the x. Okay, this one has us doing a complete the square. Okay, so the completing the square is you ending a trinomial. That's kind of the goal. So let's get that out of there so we can work on finishing a trinomial. Okay, is this the time to finish the trinomial? No, it's not the time to do it. Why can't I do it here? Because it is a complex trinomial. So you have to make a simple trinomial. You have to get it into a simple trinomial. So -2 out. Get that out of there. Okay, so this is going to be a simple trinomial. So if the -2 is out, this is just an x squared. So that times that is that, yep. What do I times in the middle now? Instead of 16, plus 8x. Right, this times this, good. This times this is that, right? Okay, now it's create a value right there. I want you to figure out, just plop something into that. It's your creation. What are you going to pick to create there? Half squared, got that? Half 4 squared 16. And I could do that because it's a simple trinomial there, right? I got that into a simple. Okay, remember that you created that. It wasn't even there. So now we have to bounce this back out. And what are you going to put onto the other side of that teeter-totter? -32. Okay? This times this existed. This times this existed. This times this wasn't there. So y minus 3, -2, something that's going to make a perfect square. X plus 4 squared on the outside. I get a lot of forgetting the squared, or I get people putting a squared on the x here. That's not correct. Your squared has to go on the outside. And it's a little bit easier now to see your vertex, right? -4, comma, +3. Okay? Yesterday I was helping an MCI student with this stuff. They're doing it right now too. And they did this on every single question instead of -b/2a. They didn't learn that at all. So they were doing this complete the square every single time just to get the vertex. Okay? For you, because I showed you that little trick with the -b/2a plug in, which method would you pick? Would you rather do this to get the vertex, or would you rather do -b/2a plug in? Okay, so on your test, if I'm saying find the vertex, you may as well pick that little -b/2a. It's shorter. Okay, so really the only time you would ever do this is the question on the test that says do this, complete the square. Okay, otherwise it doesn't make sense to do it if you have a little bit of a shorter tool. Okay, just super quick before we do the word problems here, let's talk about throwing a ball. You don't need to write this down or anything. I'm just going to, unless you really want to, but you can in the back. The back is blank if you want to write it. Okay, if I was to throw a ball, I would do this. This would be the time, and this would be the height of the ball. Technically, I wouldn't draw any of this section. Why wouldn't I do that section? Negative time. That doesn't work. So, in the real problem, it would start just there, which is the y-intercept. What will this tell me about my ball situation? So let's pretend this value was 8. 8 is the what? 8 feet is the what of the situation? Starting height of the ball. That's the release point. That's the height of it when it's released. Then eventually that ball will get to a maximum. So you're going to have an x value of the vertex, and you're going to have a y value for the vertex. I put this little v there because it's of the vertex. So what's this x value? So let's pretend it was at 2 seconds. So that is going to be the time to do what? To reach the max. That's how long. That's the how long it's going to take you to get to the top. And then this value is going to be the highest height you can get to. How long it takes you to get there, and then what is the highest height. Okay, I'm also going to not be drawing that part of the graph. Why wouldn't I include that part of the graph? The ball is going to be into the ground, question mark. So then I'm going to stop on x-intercept. That's an x-intercept. So what is that going to tell me? So let's pretend that it was 11 seconds. So what is it telling me? 11 seconds is how long it's doing what? Time to hit the ground, really how long in total it traveled for in the air. Okay, so you need to have that foundation. I might talk about that question on a test, being able for you to just openly describe this situation. Like, what's going on? Why am I crossing this out? Or what is this representing? Okay, when you connect it to a word problem. So this sports store is selling baseball hats, and they sold 600 caps, 15 bucks each. They're trying to make revenue. So making the money. So how much each hat is, the price of this hat, times how many hats, that's going to make me my money. So for instance, I would just sell 600 for 15 bucks each. I would just times that, and that's how much money I would make right now. So timesing those. Okay, everyone's good with understanding that? Okay, so I'm going to use brackets to represent the price, and then another bracket to represent the number of hats. Okay, so a store sold 600 hats at the start for $15 each. They're trying to get the largest revenue, and it's indicated that if they were to increase by $1.50 on their price, so this would increase by $1.50, then there would be a decrease of 30 hats. What am I missing? An X. So $1.50, you don't know. You might do it once, you might do it twice, you might do it 3 times. You don't know. But for each time you do that, what happens to the 30? So if this goes up twice, this goes down 60. Okay, what would your next step be? I need you to give me some foiling on that. Okay, this is good. We did the FOIL. I collected those 2 terms. Okay, so we're trying to do a max revenue, and I do know that this is opening down, negative 45x squared. So I'm trying to figure out maximum. So a vertex. Vertex is a maximum. How do you get vertex when you look like this? negative b over 2a, plug in that method. Okay, negative b over 2a. So negative 450. Don't forget your a. I didn't write them in order. I wrote like C over here and A is over here. Right? It's not about what's first. Okay, so I'm getting 5. I get this a lot. I get people who answer that that is the price of the hat. Okay, that is not the price of your hat. What does 5 mean? 5 is your x. X in this case is how many times you change it. That's all the x is how many changes did you make. So we went up $1.50, $1.50, $1.50, $1.50. We did that 5 times. So what is the price of a hat going to be at? So we started at $15. So I'm really just going into this bracket here. We started at $15 and we increased $1.50 5 jumps. So each hat you should sell for $22.50 to get the best of your money. I have a second question here that says, what is the highest revenue you can make? So where do we figure out the revenue? Plug it into this whole line right here is the revenue. So again, to figure out the price of the hat, I just plugged it into the bracket, just that chunk. To get the revenue, I'm plugging it into the whole thing. Somebody will yell at me if they're not matching. Okay, so on this test question, please just make sure you understand where you're plugging it into, why, what am I finding. Plug in here for price, plug in here for revenue. Am I getting a match? Somebody? Yeah. Okay. Okay, number 8, the last one. A rectangular fenced area is to be made to enclose animals. There's going to be one fence line down the middle to divide it into 2 sections. So that's your drawing. You were given 300 yards of fencing, so all of these sides are 300 yards worth. All of those sides are 300 yards of fence. So I'm going to say that it would all add up to 300 if I could add those sides of fence together. Okay, on a test you have to pay attention. If I put along a barn, how would I draw this differently if there was a barn? I wouldn't have a fence line on this side at all. I would just forget that side because the barn will block the animals for me instead. Okay, let's talk about maximizing the area. Area of a rectangle. Area is always something squared, so area is quadratic, squared. This is a problem, too many letters. You can't have an equation with 3 letters going on. Okay, obviously up here we had an R and an X, 2 letters. Good. But now I got 3 letters. So we're going to maneuver some stuff here. Which one is easier to get alone? Would you want the L or the W alone? I always pick the fewer, so the 2L is easier alone. So I moved that over. Okay, I get a mistake here. Some people try to put that together as a 297W. That's not what that is, right? Can't combine them. What do you do if you want to divide by 2? What do I say there? It's like giving candy to children. If you divide that by 2, you have to do that to every single thing or somebody's getting mad. Okay, so this is the same thing as an L. So now I'm going to go to the L. So this is L, so I can replace it, right? Okay, so all I did there was make a substitution of an equivalent partner. Okay, so this point on is the same as your revenue question. So what kinds of things are you doing? You're going to do a FOIL kind of idea. It's not a full FOIL, it's just a distribution. So times the brackets out. You want a vertex because this thing is opening down, negative 1.5 W squared. It's opening down. You're trying to maximize, so you need a vertex. So the vertex process is at negative B over 2A. Do you understand that there's just no C value in this equation? That's not there. So be careful, what's your A and what's your B? Okay, again, A is not the first thing. A is how many x squareds you have. Okay, so I got 50. 50 is the x. Wait, it's not an x value. Instead of x, what is it this time? What letter do we have instead of x? W. So this is what I know. 50 yards is the width of the triangle, or the rectangle. Okay, now we're going to take that and we can do some plugins. Depends on what I want. If I say area, you would plug it into here. If I say what are the dimensions, I would plug it into here because this would give me length and this would give me area, right? Do you see the different outputs? The output of this is area, the output of this is length. So I want the dimensions. So I'm going to plug it into the length. Okay. If I did ask for area, you actually could do two things. You could just times those, because it's length times width. You could times those numbers, or you could plug into there, because they would both get you the same number.